All right, guys, we're going to be looking at graphing standard form equations. So we're used to seeing our slope-intercept form, which is our y equals mx plus b, where m is our slope and b is our y-intercept. Okay, but you notice on this page, you see equations that are in standard form, which is our ax plus by equals c. Okay, so the thing about standard form is that it doesn't give us any vital information, meaning like when I have slope-intercept form, I know I have my slope and I know I have my y-intercept. But when I'm dealing with standard form, I'm going to have to solve this out first and convert it to slope-intercept in order to get my graph. So let's look at the first one. I'm going to just write this out to the side. So my goal is to isolate y. I want this y to be on a side by itself. So I'm going to draw my line just in case I needed to separate my left side and my right side. Then from here, I'm going to do inverse operations. I want to get this 7x on this side because I want just my y on the left. So I'm going to do inverse operations. So if I have positive 7x, I'm going to have negative 7x. And one thing I do on one side, I do on the other side. So this cancels out here. Now notice on this right side, I put the 7x. I didn't put those together. And that's because these are not like terms. So I cannot combine those. So when I bring down my equation, I'm going to have y equals 5 minus 7x. Okay. So then from there, I'm going to say my slope, or identify my slope and my y-intercept. So my slope is negative 7 and my y-intercept is 5. Now, if you notice, of course, we use y equals mx plus b, but they can always switch it and put y equals b plus mx. It's like if I have 2 plus 4 and 4 plus 2, that's both going to be 6. So we can do that. So just keep in mind, this was here in our y-intercept place. And then our slope was here. And I had to take that negative sign. Okay. So when I graph, we know we begin with B and we move with M. M is our rise over run. So I can go ahead and put this 7 or negative 7 over 1. So I know that I'm going to be going down 7 and over 1. So I'm going to start at 5. And I'm going to go down 1, 2, 3, 4, 5, 6, 7 and over 1. Okay, and that's all the points that can fit on this graph. So I'm going to draw my line. And there we go. Okay. Another thing you can do, once you have this solved out for y, you can use Desmos. Okay, I know a lot of you don't really use Desmos, or if you have a TI Inspire, you can do that too. But one thing you want to do is you can just type in your equation. So y, what was it? I forgot what it was. Let me go back. So you have y equals 5 minus 7x. So I could just type in y equals 5 minus 7x. And there's my graph. So on here, I can zoom in and I can, get some points and plot my graph if I want to, if that's easier. Okay, but you should really just be using this for a check. You should know how to start at your y-intercept and use your rise over your run to move. Okay, so I'm going to keep going. As you see, I've done some examples. I'm not going to do all of them because I want you to try this out on your own. So let's look at number 2. So this time I have a coefficient or a number before our y. So it's going to be a little extra step in there. So I'm going to move this 3x to this side. Okay. So once I move the 3x, what I do to one side, got to do to the other side. So that cancels out here. I'm going to bring down 5y equals negative 5 minus 3x. Remember, like I said, we cannot put these together because they are not like terms. So from here, I'm going to divide by 5. Now, one thing I want you to keep in mind is it's 2 ways when I divide, okay? I'm dividing both sides by 5. So I have my 5 in my denominator, but this actually applies to both terms. So I want to write it separately so that it's a little easier for us to follow. So this cancels out here. I have y equals -5 divided by +5 is -1. And then here, that's already simplified. So I'm just going to bring down -3 over 5x. Okay, a lot of people were asking, hey, can I put it in a decimal? You don't want to do that here because you have your slope. So if you have a decimal, you won't be able to see that rise over your run. So let's go ahead and graph. We know that our m is -5 over 3 and our b is -1. So I'm going to start at -1 because remember I begin with b. And I'm going to go down 1, 2, 3 over 5. Okay, then from here, I'm going to go up 1, 2, 3 and over 5. And I'm getting this other point because when you graph, I want you to be graphing every point that can fit. So yeah, we had another point that could go there, so we're good to go. All right. Now, number 3, we did last week. This is actually in slope-intercept form because it's y equals. But you just have to remember that if you don't have an x term, that means that slope is not there, which means that it's 0. And that y-intercept would be that 4 that's there. So if I'm starting off at 4 and my slope is 0, it's going to be a straight horizontal line that's here. Okay, now number 5, I'm gonna let you do on your own, but it's kind of the opposite of what you're doing. Your slope is going to be undefined and your y-intercept is going to be none. So I'm going to let you try that on your own, but that's a little hint. And I'm going to do 2 more on the back side. So if you have a printer, hopefully you are able to print this out. So I'm going to do number 10. So 10x minus 3y equal 15. So I'm going to subtract 10x from both sides. I have -3y equals 15 minus 10x. Then let's divide by -3. So again, I'm going to separate those so I can see how I'm dividing each term. So this cancels out here. I have y equals 15 divided by -3 will be -5. And then here I got -10x divided by -3. That's going to be positive 10 over 3x. So then I'm going to start at -5. And I'm going to count up 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then over 1, 2, 3. And that's my graph, which I do want you to be putting your m equal and b equal on each equation. So I know that you know the slope and y-intercept. And then I connect my dots. And that's it. So here, let's look at number 9 because this one, it doesn't have a coefficient. So some of you may get confused. But you do know when you have just variables, you can put a 1 in front. So if you need that 1, put it in. If not, then you don't have to worry about that. Okay, so I still want that y on the side by itself. So I'm going to move this x over. So I have to do the opposite, which is subtraction. And what I do to one side, we do to the other side. So we're going to have -y equals 3 minus x. Then from here, notice I have -y. So I'm not done because this y has to be positive. So I'm going to divide. And here we may want to actually put that -1 so we can see that we're dividing. And I'm going to divide each term by -1. So I have y equals -3 because I had 3 divided by -1. And then here I got -x divided by -1, which will be positive because you had 2 negatives divided. So that'll be positive 1x or just positive x. Okay, it may be easier here to write the 1 because once you identify the slope, you know that slope is 1 because that's the coefficient. And your y-intercept is -3. So from here, starting at 3, and if my slope is 1, that means I'm going to go up 1 and over 1. So up 1, over 1, up 1, over 1 each time, okay? And then I can get the rest of these points. So down 1 over 1, we know our slope is positive, so that line has to be going up. And that's it, okay? So I want you to go ahead and finish out the rest of the problems and see you next time.